Hello, Math 110 class, and welcome back for section 4.6. We're first going to start off by solving more log equations. And so you'll notice that we have a log, which is the common logarithm or the base 10 logarithm on both sides. So just like last section, what we're going to do is recombine the left-hand side into a single logarithm. This is the log of x minus 4 over 3x minus 10 equals the log of 1 over x. And now that we have two logarithms that are equal, that means that their inputs must be equal. So x minus 4 all over 3x minus 10 must be equal to 1 over x. So let's go ahead and write that out. Okay, and now we have an equation here where we have two fractions on either side, one on either side. And so that means the best way to solve this is using what's known as cross-multiplying. So what that tells me is that x times x minus 4 has to equal 1 times 3x minus 10. And so simplifying, we get x squared minus 4x equals 3x minus 10. And the way to solve quadratics, class, is to move everything to one side and factor if possible. Otherwise, use quadratic formula. So moving everything to one side, we get this, which actually does factor into x minus 5, x minus 2. And from here, this tells me that x can be 5 or x can be 2. And now we need to check our answers, right? If when we plug in 5 or when we plug in 2 back to the original, do we get a negative inside any of the logarithms? Well, you notice if I plug in 2, I get a negative inside this logarithm, so automatically 2 is no good. But I think 5 works, because here I would get a 1, here I'd get a 5 on the inside, and here I'd get a 1/5. So I think this one works. And so x equals 5 is our only valid solution. All right. So pause the video and try this one if you're up to it. Otherwise, we'll hop right to it. You'll notice that we have a bunch of log base 3's, and then we have just a lone number 2 here. So what we're going to do is actually get all the logarithms over to one side first. This is different from the last problem where we had only logs as part of the problem, but here we actually have just a single number 2. So we have to treat this a little bit differently. So we're going to get everything over to one side. And so what that tells me is that I get log base 3 9x squared plus 4 minus log base 3 x plus 2 minus log base 3 x minus 3 equals 2. Okay. And now we can recombine the left-hand side into one single logarithm. So this is log, and give yourself some room here. Anything with quote-unquote plus in front goes in the numerator. So this factor 9x squared plus 4 goes in the numerator. And now these two factors have minuses. So they'll be in the denominator. So we get an x plus 2, x minus 3 in the denominator. And you'll notice because these get multiplied in the denominator, I'm using parentheses here. Okay, so we're just using our properties how to recombine logarithms into this single logarithm. And now what this tells me is that, well, I can switch this to exponential if I use a triangle. So at the base of the triangle, we'll go a 3, and this 9x squared plus 4 over x plus 2, x minus 3. And on the top goes the 2. And so this tells me that 3 squared, which equals 9, equals this fraction here. So let's find some room here. And so 9, which is 3 squared, equals 9x squared plus 4 over, and now I'm going to expand this out. I get x squared minus x minus 6. And now I can cross multiply to solve. So technically this is like a 9 over a 1. And so what I get is I get 9 times x squared minus x minus 6 equals 9x squared plus 4, technically times the 1, but that doesn't change anything. And so simplifying, I get 9x squared minus 9x minus 54 equals 9x squared plus 4. And you solve this, you'll notice that you can subtract 9x squared from both sides, and it actually cancels, so that's nice. And so I get minus 9x minus 54 equals 4. So if I add and move some stuff around, what I get is minus 9x equals 58, which I can divide by minus 9. And I get x equals negative 58 over 9. And we check if this is a valid answer or not. This number is definitely less than negative 2. And so right in here, that would make this inside of this logarithm negative, certainly. So in fact, this answer is no good, and in fact, we have no valid solution, since that was our only possibility. And so some problems work out like that, right? Okay, now let's learn how to solve exponential equations. There's actually 2 strategies you can take here, so we'll go one at a time, and then I'll make this part of a larger discussion. So the first thing you can do is actually use a triangle. So this is 4 with an x and then a 17. And so what this says is that the log base 4 of 17 equals x. If you just switch to a logarithmic expression. And you see, okay, we've solved for x. X equals the log base 4 of 17. The alternate strategy you could do, and this is going to be our typical strategy moving forward, is you're going to apply the, let's say, natural logarithm to both sides. You have your choice, but I always like to do the natural logarithm. So I'm going to take the natural logarithm of 4 to the x, and that has to equal the natural logarithm of 17. And the reason I know that is that these two things are the same. 4 to the x has to equal 17. So if I plug them both into the logarithm, I get the same answer, right? And now I use properties of logarithms. So this says x times the ln of 4 equals the ln of 17. I'm using property 3 from last section, where I have an expression to a power, so I can bring the power out front. And now this tells me that x equals, well, just divide both sides by ln of 4. And that's it. I want to caution you, class, the ln's do not cancel here. There's nothing like that. They don't behave in the same way as, like, if this was a number times 17 divided by the same number times 4. The ln is not really a number. It doesn't cancel like that. And so this is our answer. And so you notice we actually have 2 different expressions for x. And so many years ago, mathematicians noticed this, and what they came up with is that, okay, these 2 answers have to be the same, and that gives us what's known as the change of base formula, which says the following, that if you want to compute the log base, let's say b, of an expression u, well, pick your favorite logarithm. That is, let's say the log base a of u divided by the log base a of b. And so in this case, I guess the base a would be e, right, because I have the natural logarithm here. But that's just a neat observation, and this is actually how calculators will compute logarithms for you, and how you can compute them on your own, right? If you wanted to compute log base 4 of 17, well, you don't have that key on your calculator. However, you do have a natural log key. So you would do ln of 17, end parentheses, divided by ln of 4, end parentheses, hit enter. And if you want to know, let's see, do I have this answer? It's roughly 2.04. And some other stuff. Okay, but let's actually use this technique 2 to solve for exponential equations where the base is not the same. So you'll notice here I have a base 3 and here I have a base 4. In the past, like maybe I would have had a base 9 and then I would write it as 3 squared and then, set the powers equal. But I can't do that here. There is no nice power of 3 that equals 4 and vice versa. So what I'm going to do is actually, what this gets me, just like the last problem, is that the ln of this has to equal the ln of the right-hand side. And now use rules of logarithms. This is an exponent x plus 2, so it can come out front. And look how I do this. It's x plus 2 with parentheses, ln of 3 equals parentheses 3x minus 1, ln of 4. And now what you do is you expand both sides. So let's make another arrow here. I get x times ln of 3 plus 2 ln of 3 equals 3x ln of 4 minus ln of 4. And now what I'm going to do, class, is I notice that here I have an x and here I have an expression with x. I'm going to get these two to the same side and everything else to the other side. So the way that's going to look for me is I get, how about x ln of 3 minus 3x ln of 4 equals minus 2 ln of 3 minus ln of 4. And now the reason I do this is that now I can factor an x from both terms here. And so another arrow, I can factor out an x, and what I'm left with is ln of 3 in parentheses minus 3 ln of 4. And that equals minus 2 ln of 3 minus ln of 4. And now to solve for x, look, just divide both sides by everything in this parentheses here. So one last arrow here, I get x equals minus 2 ln of 3 minus ln of 4 all over ln of 3 minus 3 ln of 4. And it's okay if you leave your answer like this. I think this looks just fine. Whoop. Okay. All right, so let's try this with another one. If you want, go ahead and pause the video. Try it yourself. But we're going to hop right in here. So you'll notice there is no nice power of 2 that gets me 3. So I can't rewrite 3 in any meaningful way. So I'm going to take the ln of both sides. And what this gets me now is that I get 2x minus 1 in parentheses times ln of 2 equals 2 minus 3x in parentheses times ln of 3. Distribute. So this is 2x ln 2 minus ln 2 equals 2 ln 3 minus 3x ln of 3. Let's get this term with x and this term with x on the same side of the equal sign. So I'm just going to add it over and then add the ln of 2 to the other side. So what this gets me is 2x ln of 2 plus 3x ln of 3 equals 2 ln of 3 plus ln of 2. And now factor out the x and then divide by, at long last, the stuff left over in parentheses. So x times 2 ln of 2 plus 3 ln of 3 equals 2 ln of 3 plus ln of 2. And that tells me then that x equals, big division bar, 2 ln of 3 plus ln of 2 all over 2 ln of 2 plus 3 ln of 3. And you'll notice I'm not trying to cancel the ln's or anything like that. There's not much more you can do with this, so we're going to leave it like that. But this ln of 3 does not cancel with this one, nor does this ln of 2 cancel with this one. That's not how division works. So typically we're just going to be happy with an answer like this. Okay. Next type of problem you'll see on the worksheet especially is where you have square roots involved. And so what we're going to do is we're actually going to rewrite this as the log of x cubed minus 9 all to the 1/2 power. That's what a square root is, which I can bring now the 1/2 down, like so. Remember, this log splits up no further. I can't do anything with the 3 or anything like that. I have this minus here, which is really stopping any further progress. But what I can do now is I have a 1/2 here, so I can get rid of it by multiplying both sides by 2, and I get log of x cubed minus 9 equals 4. Okay, well, this is a base 10 logarithm, so in fact I now have 10 x cubed minus 9 and then a 4 at the top of the triangle. And so what this tells me is that 10 to the 4th has to equal x cubed minus 9. Oh, well, now I can easily solve this for x by adding 9 to both sides. And if you're curious, 10 to the 4th is 10,000. So this is 10,000 equals x cubed minus 9. So add 9 to both sides. And then just take the cube root of both sides. So x equals then the cube root of 10,009. And it turns out that odd roots are like unique, so there is no plus or minus. If this were a square root, maybe you'd have to do a plus or minus, but it's a cube root, so there's only one answer. Okay, and now some other types of problems that you'll see on the worksheet. Here we have x to the log, or square root of log x equals 10 to the 8th. This is a very strange problem, I admit, but you'll notice that I have a log x here. And so what I'm going to do is actually follow the lead and use a log x on both sides. So what this gets me is that the log of x to the square root log x equals the log of 10 to the 8. And now this actually works out because this is a base 10 logarithm. And so the base 10 logarithm of 10 to the 8th is just 8. And over here, I can use rule 3 from last section and bring this whole power down. So I get square root log x times log x equals 8. Now, let's see. This is technically log x all to the 1/2. Times log x equals 8. And so technically this is like to the first class. And so we have the same base here, and I'm multiplying, so I just add the exponents. So what this gets me is that I really have log x all to the 3/2 power. Right? Just add the exponents, 1/2 plus 1 equals 8. And now I can solve for log x by taking the 2/3 power of both sides. So I get log x equals 8 to the 2/3. If you're wondering what that is, you first do this number as a root, so the cube root of 8 is 2, and then square your answer is 4. And so what I really have here is log x equals 4. Well, this gives me a triangle now, 10x with a 4, and so x must be 10 to the 4th, which is 10,000. Okay, so there's one like that on the worksheet as well. So just kind of follow my lead here. I think the problem involves an ln, so instead of using normal log, use the ln, and then just kind of follow my lead here. Okay, and now finally, this is a very strange problem, admittedly, so we're going to try to solve for x here. Let's notice first we have a triangle. This is a base 10 logarithm, so we have 10 here, log x here, and a 2 here, right? So what this tells me is that 10 squared, which is 100, equals log x. Oh, well, if I just rewrite that as log x equals 100, I now have another triangle, right? I have another base 10 log, x over here, and then a 100 up here. Oh, so this tells me that 10 to the 100, which is a very large number that I'm not going to try to simplify, equals x. And I think we're done, right? We've solved for x. All right, so that is the end of Chapter 4 material. Work on the worksheets and turn them in by Friday, April 3rd at noon. And by turn them in, I mean upload them. Starting in the next video, we're going to get into Chapter 5, which involves trigonometry.